finished, Omar?
Yeah. Mine is. I only have to do the hard work.
Well, did you take a look at mine? No. No.
You're smart.
Yeah.
I'm sorry, Omar, I'm crazy busy. I don't know what to do.
How do you get this to start?
Was that what you were trying to do?
Yes! No, really, how do you get this to start?
I made
a command.
DIFC.
That's it?
I made a command called DIFC. It opens up my Paint program, sets the microphone volume, starts the screen capture.
Wow.
Automates everything. And then when I'm finished, I type in YouTube, converts it to MP4, and uploads to YouTube.
Yeah, just make sure that the mic is still working. And
There should be. There should be sound in the videos. Nobody has emailed me saying...
No, just make sure that it's working.
It will be. Trust my programming skills. The microphone is automatically turned on and set to 50%.
Yeah, because I was playing with the laptop, so check in case I have done something.
Okay!
Don't want you to lose any valuable.
It's not me that will lose, it'll be you, because it's the videos you watch. Let's have a look. Let's see. Volume control settings. See, you can see the video increasing in size as it records, and then it gets quite large because it's MKV, and then at the end it converts into MP4. Right, there is my voice. Oh my goodness, and it seems to be fine. I need a test message. I don't like biso. I don't like. Yep. Seems to be working just fine.
Did you see the fire alarm?
What, did you see the fire alarm? There was a big aircraft flying with fire alarm.
Earlier I heard a fire alarm go off.
No, just now.
Just now?
Yeah.
Minutes ago.
Where?
We were kicked out from the cafeteria.
Wait.
Something burned in the kitchen? What happened?
No, the first intake students pulled the extinguisher.
Did they really?
Yeah.
Nice. Do you know who? Or is that a secret?
It's the old guy with the afro hair. Pretty sure Egyptian.
Yeah, no, that really narrows it down. It could only be one person, maybe two I can think of.
No, he's the tallest guy in there.
Then it's only one person. Hisham.
Hisham, yeah.
Oh my goodness, why did he do that?
Why did he do it?
When I see him, I'll ask him for it.
Well, in the canteen? What's there to gain? Like, I can understand doing it in the classroom because then you can skip the class. But what's there to gain in the canteen? Like, oh no, now I can leave the canteen.
This is our class for free.
What?
This is our class for free.
None of those other so-called students skip class to work on their essay.
Yeah.
So-called students. How's your essay coming along?
Oh, perfect.
Is it?
Oh my god, I am waiting for a job offer from NASA.
Oh, great. Oh, look, we have more students. Great. Come on, what happened to you? Again?
No.
Guys, you're going to get a reputation for being idiots. Come on.
As if it's not out already.
Give him a slap. Across the face. Come on.
I'm not that
Wipe that smile off his face.
What did you say the maximum word in it?
I don't remember. Leave me alone. What word count are you on now?
What?
What's your word count?
What? Do I have to say it out loud?
Go on.
1,550 without a
1,550?
Without a condition.
Don't know, man, you're pushing it pretty far. You might want to start cutting stuff out.
Could you give me some words?
Yeah.
Just pass me on the
What's your word count?
With the references?
Yeah.
Wait, with the
Hang on. What's your word count?
900.
With the
Without for you. Yours is at 1500 with the reference?
No.
Oh no, you see, I am going, for you it does count.
That's the conclusion.
Yeah.
Is the referencing does or doesn't count?
It depends on the student.
Could you like tell us specifically like
No.
it's counted for you?
Do you want write more than 1,300? That's alright.
What is it?
Yeah, talking to him.
Yeah, he needs to worry.
I can't.
What lesson are we on now?
800.
Do you know
Oh
how
yes.
far did you reach?
Well, I'm listening.
How far did you reach? How many words now?
600.
لا man, لا.
When are we supposed to submit it tomorrow? You're
telling me to explain rocket
What
science
time is your first class at?
and astronomy
I have
in less than 1,000 words.
speaking.
Yeah, I know. It's not easy.
For me, it's
And this is my problem.
No.
Some people start at 12, some people start at 9.
The listening?
Yeah.
No,
Speaking.
it's just 3 and we start at 10.
No.
15 minutes each.
Yeah.
Hang on. Tomorrow is what in the morning? Some kind of listening exam or speaking exam?
Speaking.
And you all of course have different times. So who is first?
It's just 3 groups
Yeah.
and we start at 10. So by 11 we'll all be done.
My question was, and this is
Where's the
carefully,
first group?
thank you. You're the first group and you're fine. You're at 10, is it? And the last group start at.
10. So
There's going to be 3 different teachers for 3 different groups.
No.
They give it's a time slot. All
Yeah.
3 are on the same time slot. 10. So they'll go.
But of course you can't all be at the same time.
Yeah, they
someone
go.
goes first on them.
Whoever is first there, is it?
10, 10, 15, 10, 30, I think.
Fine, so the first one will be at 10 and the last one will be at 10:30.
But Lee starts at 12.
11. That's
No, it doesn't.
11.
That's all.
11.
Why is yours at
He
11?
doesn't.
No, he doesn't have speaking. That's the thing.
He doesn't speak?
He spoke today. He has his exam today.
You had your exam today?
Yeah, me and Lee, we did.
Yeah, so.
Fine, so I don't care about him.
Yeah.
You will have exam at 10.
Yeah.
So then maybe I'll email Sylvia and make the submission time between 9 a.m. and 10 a.m.
No, between?
No. I'm not making special arrangements just for you.
Can I take like, let's say these things and submit it with mine?
No.
No.
Your choices are submit before 9 or submit between 9 and 10. Which will you choose?
9 and 10.
Smart choice.
And then for each marks?
I will email Sylvia during this class to let her know that you will be delivering your assignments between 9 and 10. Do not deliver before 9. Not that you will, but Sylvia needs a time slot, so not before 9. But why would you be?
Can't you just wait?
Can't you wait until 9?
You're coming, what did you want to do? Study?
Yeah.
Study, 9:30, take a break, go, come back, study.
Yeah. Right, let's have a look here. So I said I'll do an example because we were kind of in the middle of this last time, correct?
Yes.
But I don't think I did any examples.
Yes. That's why I couldn't do the homework.
I didn't ask you to do this on a
Yeah, I tried doing it, and I failed miserably.
So I guess what I do in class is useful, huh? I mean, I do have some use. It's nice to know. Right, come on. Right. We'll do this one together, and we'll do it ABC. So you just need to write or draw part A, and then I'm going to do it.
Question.
Yes.
Can you go to the previous slide? No? Then after. No, I mean the other way.
Okay. This way?
Yes. Can we do this type of referencing?
Goodness,
the
no.
same?
No. Have you seen Sotero?
Oh?
I don't know how to use it. I use type discriminate.
Oh.
It's a way to use reference. It does all the references.
What is this?
After we do some physics tutorialing, we will have a look at maybe some coursework pointers like Sotero.
So you can just do that in Word.
Sotero?
Like,
The reference?
automatically reference for you. Harvard class.
Word has an add-in for referencing?
Yeah.
Soltero?
No. Yes, I promise you we'll look at this later. Can we go back to...
If you were nice to me, I would have showed you.
That's too difficult. Please, can we look at this? And then I promise you, afterwards we'll give a little bit of time to things like Sotero and stuff like this. Okay, so the first part, in fact, you can do. What is the formula for refractive index? Do you remember it? Speed of light over C over V. Okay, so try part A, please. Right, you should have it finished by now, the part A. So part A, M equals C over V equals 3 times 10 to the 8 over 2 times 10 to the 8, which equals 1.5. Did you get that? Yes? Okay. B. I give you N1, I give you the angle, can I give you the refractive index of air? Red light enters the block of glass from air at an angle 20 to the normal. What angle does the light travel at after entering the block? That's strange, I didn't give you the refractive index of the glass, so I'll tell you what it is now. It's 1.33, we'll say. No, we'll make it, we'll make it 1.33.
Same happens with the fractions of the whole, I think. I found that too.
Okay, we'll see. For this one I should have said 1.33, so... Okay, try this one. M2 is 1.33. Oh, sorry. Finished it? Let's have a look. It's not super long to do. Right, so let's have a look here. The air is 1 and the glass is 1.33 and the angle here is 20 and we'll want the angle here, we'll call it x. So we have sine 20 over sine x equals 1.33 over,
No, it's the other way around.
is it? I thought it was sine 1, theta 1.
Oh yeah, that's for the V, it changes.
Yeah. So we have sine 20 over 1.33 equals sine x. So x equals,
0.7.
you have it there? That seems awfully small. (14.9 degrees). Are you in radian mode?
Yeah. Sine 20
Yeah.
over 1.33.
They're not supposed to be radian.
Yes.
Sine 20 over 1.33. Shift sine answer.
You're not supposed to be in radian mode.
Are you listening to him? He said it 3 times now.
Oops.
Oops, you did it again. Right. C part.
Wow. That was a big twist.
Okay, that's great. C part. Now some light is shone from the glass to the air. What is the critical angle here? So at this time the light is going the other way. It's going from the glass to the air, and I'm looking for it to be a critical angle. So if you remember the formula, in this case it would be sine inverse 1 over 1.33. (48.8 degrees). Critical angle. Continue. Yep. Okay. So what we'll do is there's 6 questions and we shall take turns. You'll do one, then I'll do the answer. Questions 1, 2, 3 and 4 are all very straightforward. 5 starts getting hard and 6 starts to get hard as well. So we'll see how you do after the first 4. So we'll do it one by one. So number 1 please.
Can you have a look at question 3?
Yes, I gave you enough info. It's fine and reasonable to assume that the refractive index of air is 1 because air is like a vacuum. I mean, I know of course air is not a vacuum. It's quite difficult to breathe in a vacuum. But for light doesn't feel much of a difference between air and a vacuum because the refractive index of air is like 1.0001. So, and then in the exam, in fact, they may expect students to make that assumption about air. I think it's reasonable. How are we doing on number 1? You should be approaching an answer soon. Answer should be on the horizon, getting closer to you. Or it's still a blurry distance away. Okay, kiddies, do you have number 1 done?
I have a question.
Make it good.
Can we say lambda 1 over lambda 2 equals n2 over n1? Or we have to equate it with sign?
You could say lambda 1 over lambda 2 equals n2 over n1.
That's what I asked. Can we?
No, I think you said n1 over n2.
No, n2.
That doesn't mean you said it the right way. No matter. The answer is yes. Why do you look confused? Or is this a natural look?
No, the fifth question.
Oh, fine. Well, let's do the first one. So, what's the formula we're using in question 1?
C over V.
So, V equals C over
V.
N. Yeah. So that's 3 times 10 to the 8 over 1.33, which is 4 over 3, 9 over 4, 2.22?
2.3. Yeah, 2.3 times 10.
Okay. That's it. Okay. Number 2 now. Let's have a look at it. This is like the example I did a moment ago. I give you the ends, and I give you one angle, and I want the other angle.
For the first question, does it fit the prism at 90 degrees?
No. Have you done 1 to 4?
Yeah.
Help out some of your classmates. Be a team player.
I don't think anyone needs that.
Ah, now. Maybe you look at them differently than how I look at them. I mean, just look to your left. Yeah. Yeah. Omar, are you doing question 2? You're not. Come on now. I want you doing number 2. I'm extra cranky today because a bee stung me this morning. On the bus. I was asleep. And then all of a sudden I feel right here at the side. And my first reaction is, oh my goodness, something inside me just exploded. And then I saw the bee, and I'm like, oh, rats.
I've heard that there are a lot of bees in the summer.
Here they're okay, they won't bother you. I think what happened on the bus is I didn't hear the bee, and I was asleep on the bus, and I must have been sleeping on the bus, trapping the bee in the seat, until the bee got annoyed with me enough to sting me on my side, and then it escaped.
More like dying.
It was looking like it was nearly dead actually, because it was kind of on the window like, and it didn't have its little stinger anymore, so I'm like, I'll leave it to die slowly as payment.
C is the speed of light.
Yes,
in a vacuum.
correct.
Why do you use it for the first question?
Because, if you recall from my lesson on electromagnetic waves, I said that the speed of all these waves is c. It was one of the 3 properties of electromagnetic waves. They travel at speed c, they are transverse waves, and they travel in a vacuum. Surely you wrote these 3 properties down. Electromagnetic travels at speed. And radio is an electromagnetic wave.
So they all are as fast as the speed of light.
They all are in fact technically light, but just at different frequencies. A radio wave is just light at a low frequency. It's not in any way. different, special. An X-ray is just light at a high frequency. The only difference is light, what we call light, we can see with our eyes. Have you got number 2 finished yet, Yahi?
Yeah.
Nobody's listening to Yusuf about... Okay.
You gotta agree with small amounts.
It should be... How small? You have the second answer? What you got?
32.1.
That sounds reasonable to me. Let's have a look at number 2. So, what's the I here? Do we know the I, or is that what we want? We do. And we don't know this. And it goes from the water to the air. Did you have it upside down? 1.33 sine 45 equals sine x. 1.33 times sine 45 equals x. Sine inverse that. And, no cigar this time. Although I feel like I made a mistake here, because...
Yeah.
Hang on, let me find my mistake. This is how I learn, okay? We are going air to water.
No, I think you should do it in an entirely different way.
What?
No.
You are talking crazy talk, Yusuf.
I used like velocity or speed instead of...
No. Go back to the solving.
I should have sine 45 over sine x equals 1.33 over... It's upside down. I'm the one who's wrong here. 1.33 over 1. So this one should have been then 1 over 1.33 sine 45.
Let's just set 2.1.
Fantastic. Sine 45 divided by 1.33, and then sine inverse that, and we get the 32 as promised. 32.1.
The thing is, I got 32 for like same answer. 32.
Yeah.
Yeah, it is the right method, but it's really way longer.
Not way longer. You did it by looking at the velocities.
Yeah, I just used the velocity I got from question 1.
Oh.
But it's a different question.
Yes,
But it is
the same.
it is still right, because radio is the same as light, and the index is the same. So yes, I'll allow it. 3 now, please. Calculating the critical angle here for the diamond.
Degrees 3, radians 4, fluent degree.
Is there a natural substance that has a higher refractive index than diamond?
To the best of my knowledge, no, there is not. Now, that doesn't mean that there isn't one, but I remember looking this up before, and as far as I can remember, diamond was the largest on the table of refractive indices. So, there very well could be an artificial one that's larger, but certainly for naturally occurring ones, I do not think there is anything higher than this.
What's it called? Ultra cool atoms or particles.
Yes,
The one that they use to slow down.
Yes.
the
the superconductors, isn't it?
No,
Supermagnets?
no. Ultra cold particles. That's what.
Okay.
And if an object, if a light cannot pass through an object, then it does not.
Well, the light's not refractive, so it's not right to say it has a refractive index.
Yeah.
Okay. What did you get for the critical angle here?
24.4.
Yeah, what is it? It's sine inverse
Sine inverse.
air over diamond. So you should get something like 24. Andrew, what you get or no?
You say that M1 needs to be bigger than M2?
Yeah, so the light is coming out of the diamond. So the N1 is 2.4 and the, hang on, I'll draw it, it'll be a bit easier.
It has to be from the tensor to the light.
Yeah,
It has to be from the diamond to the air.
the light coming out of the diamond. So the N1 is the diamond and the N2 is the air. And we said N1 has to be bigger than N2. And the formula for the critical angle is sine inverse N2 over N1. So in this case it's sine inverse 1 over 2.42, which is 24.4 degrees. Now, more importantly, what does that mean for the diamond? Well, this is what it means. Listen carefully. The bigger the critical angle, the more likely it is for the light to refract internally. So for example, if the critical angle was 90 degrees, then it means all light refracts back in because all angles would be less than 30. If the critical angle was 45 degrees, then half the time the light would refract back and half the time it would leave. So at 24 degrees, about a quarter of the time, the light will refract back in. The angle is small enough, and 3/4 of the time the light will refract out. So most of the time when light enters the diamond and then tries to escape, if the angle is small enough, it will refract back in 1/4 of the time.
Which angle?
The angle here with the normal. If this angle is less than 24 degrees, it will refract.
This way, though, to reflect upwards.
I wasn't thinking about when I was drawing it. This is only for anyways, how do you know it'll refract upwards?
This is the normal. It doesn't reflect this way. That's way.
Says who?
That's me.
Maybe.
It can't reflect this way. That's not reflection. Okay, it is. But like, on.
Hang on. We'll draw it here neatly. This is the normal, yes. And this is the eye here. And then if it could escape, this would be the or. But if the eye is the right size, sorry, I said if it's, I'm totally misspeaking here. But listen carefully, I need to re-say my sentence. The critical angle is the angle at which the light will escape. If it is equal to this, it will not escape, is what I meant to say. And one more time, it's been a long day. If the angle is equal to the critical angle, the light will not escape. If it's greater than the critical angle, it will also not escape. It's only when it's less than the critical angle will it actually escape. So, because 24 is quite small, most of the time the angle is bigger than this, meaning it will refract back in. So, in fact, I was wrong when I said 1/4 of the time. It's actually more like 3/4 of the time. In other words, most of the time the light actually refracts back into the diamond, and this is what makes the diamond sparkle. You're looking at the light refracting inside the diamond trying to escape. It will bounce around until it's at the right angle to escape. So, in other words, the light will probably have to hit 4 surfaces before it will escape. So,
The diamond is in that shape, or
the shape is not really that important, although I think the shape might be done in such a way to make it even more exaggerated. But the fact is, 3/4 of the time the angle will be big enough to refract back in because it's more than the critical angle. So, it'll have to bounce 1, 2, 3, maybe it'll have to bounce off of 4 surfaces before its angle is less than 24. So in other words, the entire inside of the diamond should be fully lit because the light has to bounce a few times. Yes.
If the light doesn't ever come out of the diamond.
Oh no, that would only happen if the critical angle was 0.
Is there any? Yeah, but if
No.
it happens, like in theory. Would that make the diode invisible?
No, the opposite, extremely bright. Well, no, actually, the light is...
Because it doesn't reach your eyes, so you can't see.
But these are... the statement isn't sensible because it will eventually have to escape, because it's only a probability that, you know, each time it hits the surface, I reckon it has a 1 in 4 chance of being the right angle to escape. So it can't actually continue forever.
So what about the new black substance?
That is something we'll do in semester 2. That is...
No, it doesn't get improved.
no, this is the new black nanocarbon fiber, which is no light is reflected off of it.
So what is the light?
It's completely absorbed by the material. So it casts no reflection, meaning it's completely black. If you shine a laser on it, then it will completely absorb the light from the laser. So you could have like the little red circle, and then when it crosses the material, it vanishes. Yeah. Get forward. So anyway, that is number 3. Number 4, please. Yeah.
The formula for the critical angle is in sine inverse.
Yeah.
N2 over N1. For
N2 over N1, correct, yeah.
N2 over, and for another way of stating Snell's law, it's sin theta 1
Over theta 2 equals N2 over N1.
lambda.
Oh, and if you want to use lambda, it's lambda 1 over lambda 2.
So everything's N2 over N1 except this.
Except for the lambdas?
Yes.
Yes, correct.
So even velocity.
And the V's as well, actually. Aren't they? Wasn't it V1 over V2, I think? Goodness, I don't remember. It was in the
V1 over
slide.
V2, yeah.
Yeah, it was V1 over V2. Okay, try number 4 now, please. And then on to the juicy one, 5 and 6. Got it?
Yes, waiting for 5.
Why don't you start 5?
When did I?
Why don't you start
Because
5?
I did try.
And failed?
Kinda.
Failed miserably or failed?
No.
Failed vitally or miserably?
Yeah, I started and I'm like, oh.
Screw it.
Didn't say that.
I know you did. I know you did.
I would prefer learning it from the master before making
Yeah. Do you know what BS is? I give you a clue. It's not business studies. Okay. Who has an answer for 4? We'll go with a non-Faisal. What have you got, Yahi?
41.
That is incorrect.
How did you
What have you got, Yusuf?
That's back 20.
That is incorrect. We can go with this one now.
Go, Faisal.
It goes at the right angle, it penetrates through.
Just give me the angle, man. What's
Oh,
the angle?
0.
Is that an answer? Let's have a look, okay? So, it shines through some glass, and this one here is the air, and here is the glass, and this is 1, and this is 1.5, although that's actually not important. So this line here is the normal, and what did I say? It's right angles to the glass, which means the angle here is 90, and this angle here that we're looking for, that it comes out at, well, we'll call it X. We'll pretend we don't know, so it comes out at some angle here, X. Yeah? So sine 90 over sine X equals 1.5 over 1. But what's sine 90? Well, I can rearrange this a bit. I can get sine 90 over 1.5 equals sine x. Sine 90 is not 1.
0.66.
No. Sine 90?
Yeah.
Sine 90, sine 90? I don't know.
It's 1.
Sine 90 is 1?
Yes.
It is 1. I apologize. I freaked you out, didn't I? Hey! It's not 90 here.
It's 0. Because you measure it with the normal.
You know, I know that. You don't have to explain the blank and obvious to me. I know I made a mistake. Thank you. I do not need that explanation. I'm measuring the angle from the normal, and it's on the normal. So the angle is 0. I'm very hungry, Faisal, please. I don't have the energy here. Sorry, this is sine 0. This is sine 0. Alright, let's retry that. The reason it's 0 is because the angle, the light and the normal are on the same line. There is no angle.
The question says it's 90 isn't
Two,
supposed
like
to be
90 to the glass.
It doesn't say the incident
Oh,
area.
English
Yes,
indeed.
you can't have refraction.
Yeah, the x here is 0 degrees. In fact, you didn't have to do any of this. It only refracts when it's at an angle. If the light hits the glass at right angles, it continues undisturbed. Well, not undisturbed, slows down. Yeah.
No. Does it reflect that?
No, it's not a mirror, it's a glass.
Mirrors are glass.
No, hang on. Glass window. Light will travel straight through it. Yeah. You know the difference between glass and mirrors. Can't tell if you're being... Hang on, I need my Fry Futurama meme here. Can't tell if he's being serious or... So you do...
I don't...
Okay, when we say glass, we mean always a transparent material like the window or your glasses or whatever. So the light always passes through glass. When we mean mirrors, we say mirrors, but in the exam in fact I don't remember any question that refers to a mirror in the exam. So any reference to glass or materials like this, the light is always transparent, the light always passes through it. Okay, that was number 4. Can we go on to 5 now? Yeah. I'll do number 5 because you are looking particularly tired and a bit brain dead at the moment. So we'll do number 5. Well, I'm still getting the questions done. And sorry, hands up who can do number 5? Continue with number 5. Yes. An equilateral prism is placed on top of a table and green light is shone through it parallel to the table. Refractive index of the prism is 1.45. At what angle does the light make with the table? Now don't pretend you can do it right before I start doing it. I'm not buying that.
What if I do it?
I'll wait for you. Do you want to do it outside? Well, I'll do it here.
I want to look over here.
Alright. Let's have a look at this.
Yeah, just...
Got you looking, got you looking.
1.45.
Okay. See, I know this is fake. It's like, oh, well, now that you're just about to do it, I decided I know how to do it. Right, here is the table. And on the table there is an equilateral triangular prism. So that is a piece of glass shaped as a triangle where all the sides are equal. So I need to zoom in a bit here to help. These angles here I know. What are they? 60. Okay. And what happens here is we have some light and it comes in parallel to the table. So it hits the table here like this. Now, here is the normal. So with a little bit of care, I think we can work out this angle. If this is 60, then what's this angle here? 60. This is from your maths from middle school, that these angles are the same. I know, I can see. This is 60, what's this angle? 30. So we already have the 30 here. So we can use Snell's law. Sine 30 over sine or equals n1. What's n1 here? It's r, so that's, n2 on the top. 1.45 over 1. So let's calculate the or here. Whoa, that's not right. Sine 30, given up.
I have an answer.
What's your answer?
20.2.
Okay. Sine 30 is a half divided by 1.45. That's 1 over sine or though, so if I inverse that. Hang on. You're confusing your poor tired bee-stung teacher here. Sine 30 over sine or equals n2 over n1, so sine 30 over 1.45, and then sine inverse, and I get 20.17. Yes?
Okay, but I have a question.
Yes?
Sine 30 over sine r
Yeah.
equals n2 over n1?
Yes.
Okay. Yeah.
May I continue with the question? Because we are not finished. This is not the right answer. This is the wrong answer. Because if we read the question carefully, it says, at what angle does the light make with the table when it exits the prism? It still has a journey to go. Because here, it will travel off at 20.7 to the normal. So this angle here is 30. The next angle, let me just put in a dotted blue line here. This angle here is 30, but it will now be refracted, so it's not 30, it's 20.7. So here, I'll just put a little arrow, this angle is 20.17. So now our next job is to work out, let me draw the normal. What is this angle? Yeah?
The normal.
Oh, sorry, thank you. I did that the wrong way. It should have been... This here is 20.17. Yeah. And it hits here. And we'll draw the normal again. And I'm trying to draw this nice zoom in. That's better. 20.17, and the normal is here. And I need this angle for the next calculation, right? Now, do we know that this is 90? I mean, it looks like 90, but do we know it's 90?
Yes. Because they have to intersect.
Yeah, but that doesn't mean they intersect at 90 degrees. But we do know some angles here. For example, that is 60. That one there is 60. This angle here is 90 because it's a normal. And if this angle is 60 and that's 90, what's this angle here? 30 degrees. So we know that angle. Do we know the angle this makes with the table? Okay, this is getting a bit messy. I don't want it to get messy.
We know that the prism is 60. It's an equilateral prism. So once it gets in with 20.7.
Hang on, shh. Don't say anything. I nearly have it. I don't think that's 90 in the middle. I think that's 120. Because if you look here, if I draw a line here on the ground, or parallel to the ground, this angle here I know is 30, because this angle is 30. And this angle here, by the same logic, I also know is 30, because if I could draw it symmetric, I could get this as 30, because this is also a normal. So then that means the angle in here is not 90, but 120, because it must add up to 180.
So, question.
Yes.
If we draw the normal at the same height of this one, it will be the same. But if we change the height of the normal, will it still get 30?
Yeah, because it's nothing to do with the heights, but what lines are parallel and perpendicular. Which, are you happy with this being 30 or not?
No, this is what I'm asking.
You're not happy with this being 30? Okay. So, if I just draw here then, in black, you're happy with this being 30?
Yeah.
Okay, so we're happy with that being 30. And that's my point, but we'll see it now. So here, if I draw a line parallel to the ground, that's 60. So this one here, 60.
Yes.
And this one, 30. So this one,
Okay.
30. 30 and 30 is 60. The total must be 180. So here, 120. So this angle here is 180 minus 120 minus 20.17. 180 minus 120 minus answer 39.8. And we repeat. Sine 39.8 over sine x equals n2 over n1. What is it? 1.5? 1.4? 1.5? 4.5. Okay. Let's calculate the x now. Sine 39.8 times 1.45 and then sine inverse. So I get 68 degrees. Now I know I didn't quite, 68.1 degree. Now I know I didn't quite draw it at 68, so this refracted angle should be pointed a bit more downwards. Let's do it in a red here. So this angle here is 68. Let's zoom out a bit. Zoom. Okay. So we're looking at the angle it makes with the table. Okay. Right, we know that this one is 68.1 and we're looking for this angle here. We know this angle is what? 120, because this is 60. And we know this is 90. So 90 minus 68.1 gives me that inside angle here. So that's 21.85. So the answer I'm looking for at the end is 180 minus 120 minus 21.85. I'll do it on the calculator because I'm tired and hungry and lazy. 38.15. I have bad news for you. This was an exam question recently.
Didn't you say that the angle of 21.85 is 60?
No, I didn't. That's when I drew the line parallel to the ground. This one is pointing down. Yeah, when it was like this it was 60. But now we're looking at the line pointing down.
Was it the section B question?
It was. But the next one we're going to do was a section A question.
At least we had a choice.
Yeah, but you don't know what the other questions are like. Maybe this was the best one. You know? This is based off of how many years of teaching the IFY? Is the number bigger than or equal to 0? less than 1. Yes.
Can't be.
Yeah, well, 0 is less than 1. Okay, did you write this down? In fairness though, Yusuf, this was a hard section B question, but the point is still the same. It was a section B question. It was hard to do. Even though the only thing in the question is using Snell's law twice, the difficulty is you have to fully be comfortable with your angles. Okay. Can I continue? Do you have this?
I'm not writing it down.
Okay, because you've given up.
No, because I use a different book for my tutorial.
Okay. Okay. 6. A man is standing at the edge of a pool which he knows is 1.2 meters deep. He looks down at an angle of 30 with the vertical. At what depth does the pool appear to be? So I'll let you try it, but I'll draw it for you here. And I said the refractive index is 1.33 of water earlier. So here's the man here. He's standing at the edge of a pool. It is 1.2 meters deep. The refractive index of air is 1 and of water is 1.33. Now, I won't draw the man with any height, so I'll just put him at the edge. We'll have him lying down. Looking down. So, or maybe not. Well, I forgot what I'm doing. Right, so he's looking at some point at the bottom of the pool. So, I don't know, we imagine some fish or whatever at the bottom of the pool. So, and we'll put the fish over here, make it a bit easier. So the light leaves the pool here. And here's the normal. But what happens to the light? It refracts, of course, so it doesn't travel out at the same angle. So it'll travel out at a different angle. So it should be smaller, shouldn't it?
Yes.
So I'll put it like this. And then if we look at this one, it's getting a bit messy now. No, this is ugly. Yeah, let me just put something here. If the light didn't refract, what would happen is it would just travel straight up to the man, like this, if it didn't refract. Let's just put it here. But of course, it does refract. So what happens instead is, instead of traveling straight up to the man, do you know what? We will give the man a small height. I think it'll be easier. Oh my...
object closer.
There. Right. Here's the man. But the light does refract. So instead of travelling straight, it will travel up a little bit. Like this. So, if the man sees something, it looks like instead of being here, it'll be a little bit closer to him. Now I'm worried now I've made this question too difficult, but it was an exam question, but not as difficult as this.
It's the drawing.
Yeah, it's confusing, I know.
Can we do it without drawing?
No.
It's way easier to look at the drawing.
Yeah.
Nice one.
My drawing is nice.
Draw the image that he sees.
I know. Let me think. Yeah, sorry. Yeah, no, this is the right way I had it. Okay. So, he gets some light that comes into his eye, and he thinks what he's looking at is here. But of course it's not here, it's a little bit over, because the light refracted. So, I'm sure you've noticed this, when you put a straw in water, it looks like it's bent. Things in the water don't look like they're in they're position that they look like they're in, they're not, because the light has refracted when it reaches your eye. So when he sees something, of course he thinks it's in front of him, obviously. He doesn't appreciate that it might be closer to him because the light has bent to get to his eye. So what angles do we know here? Well, we know that this is 90, and we know that this side here is 1.2. We also can know refractive index, so we have this angle here, and we have this angle here. I'll call this I, and I'll call this OR. So I can say sine I over sine OR equals N2, which in this case is 1 over 1.33. Surely I must have given you more information. Oh yeah, and I know the angle here is 30. So I have sine I over sine 30 equals 1 over 1.33. Yeah, and then I wrote these backwards because the light is coming from the swimming pool. Okay, so we can know the I now. Sine 30 over 1.33 sine inverse. 22, yeah?
He's looking down at an angle of 30.
Yeah, but I said with the vertical in the question.
Yeah, so him and the normal is 30. Because he's the one that's looking down first.
Let me have a think here. This is 30.
Yes.
So this is 30.
And the eye is
No sound.
The I is 22.
Yes.
This is 30. Yeah. I is 22. Okay, well that's actually good then. So I know the I, so I can know.
Yeah, he sees it closer than 30. With 30 it's far, but he sees it refracts 22, so it's closer.
He sees it closer. He sees it here instead of here.
Yes.
Yes.
So
Yes.
the
Yes.
eye is 22.
Yes. These are all things I wrote down.
Yes.
Thank you for your seal of approval. Actually, no, I mean, we need some logo like an F in it or something. Right, continuing. So if I know the I here and I know the 1.2, I could know this length if I wanted to. Yes? No, I'm just...
Oh, no, I'm asking the question once, so no.
Yes. Yes, I kind of do want to.
Okay, do it if you want.
Right, so you're distracting me so much. Okay. So he knows the swimming pool is 1.2 deep. And what he doesn't know is the light is refracted. So he thinks this angle here is 30 degrees. And what distance he uses for the ground is going to be this distance here. So he's not going to think of it as 1.2. But anyways, we'll get to that in a minute. Let's just calculate that distance here. What will we use here? Tan will be the best, yeah. Tan 22 equals, we'll call this x over 1.2. Yes, so x equals 1.2 tan 22. Mm. 0.48. Okay, so let's recap. What does the man see? He sees this distance he thinks is 0.48 from here to here, where really what he doesn't understand that the light is being refracted. So he sees this distance as smaller than it should be. And what angle does he think he's looking at? No, that's what it is 22, but he thinks it's 30 because he doesn't know the light is being bent in his eyes. So this looks like 30 to him. So what is the height here? He should feel it being not 1.2, even though it is 1.2. So if I call this one y, I have tan 30 equals 0.48 over y. So y is 0.48 over tan 30. So 0.83. So he thinks the pool is only 0.83 meters deep. Yes? Now, I'll show you something interesting now. Did you want to write this down? This was an exam question in section A, although to help you out they did actually draw the diagram and mark in all the angles, so that obviously made it a lot easier to do. And the good news is, I think the person who wrote this question was the previous exam writer who wrote harder questions, in my opinion anyway, although it doesn't matter which group of students I have, every year they say that the exam was hard, even though, you know, you're going to look at the past exams thinking, this is easy, this is easy, this is easy, and then the exam you get, you're like, this is hard. And then next year I'll say, what do you think of last year's exam? It was easy, like all the exams. So anyways, in my opinion, the previous exam writer wrote harder exams than the current exam writer, which is good news for you. I don't know if you'll think it's easier. So we get 0.83 here.
That's also the case for maths.
Yes, but again, it's the students' perception, so they probably won't feel like that. Have you got that, Faisal? Yes? This is a hard one, I know. The last two were hard, but they were both exam questions. Okay. I can stop this